Hello kids, welcome back to Algebra 1 with your most favorite algebra teacher in the world. I'm Miss Betsy and I'm teaching Algebra 1 using as my text Bob Jones University Press, the Algebra 1 textbook. Before I begin, I'd like to know if you can tell me what a pirate's favorite letter is. What do you mean you can't? Well, of course, a pirate's favorite letter is R. R, mateys. The letter R. So that is your lame joke for the day. We are going to pick up our study with section 7.3, which is solving simple systems of equations by substitution. Now we've known how to graph the equation of a line. What systems of equations are is where you have two lines that you're going to graph and find their point of intersection. And what you need to remember to review here is that there are three separate ways that two straight lines can interact with one another. One way in which those two lines can interact is they can be parallel to one another, like a set of train tracks. Now theoretically, if that train would run on forever, those train tracks are not ever going to touch, because if it did, well, the train wouldn't have anything to run on, so they're the same distance apart. So if you have two lines, and they're parallel to this, how many places are those two lines going to touch each other? Where they're not going to touch at all, so there's no solution of these two lines. There's no intersection. So if you have two lines that are parallel to one another, there's no solution. What is another way in which two lines can intersect? Well, I just told you the answer. Another way in which two lines can relate to one another is they can intersect. They cross each other. They have two lines. Here's line number 1. There's line number 2. The point at which they cross is called their intersection, and there's only one place where two lines will ever cross, intersection. If they are intersecting lines, there is one solution only, because we know what a straight line looks like, and we don't live in some alternate universe where you have, here's one straight line, and then this one is straight, and then it does corkscrew for a while, and then it becomes straight again. And you have all of these places, 1, 2, 3, 4, however many places where it intersects. This is not the intersection of two straight lines, is it? It's the intersection of a corkscrew and a line. So the most places, the highest number of places that two lines can intersect, if their crossing is either 0 or 1, they're not going to intersect two places. No matter how you draw two straight lines, it's not a straight line if you end up with two intersections, is it? No. It's not some strange creature from outer space either. We've showed you two ways now that straight lines can interact with one another. They can be parallel to one another, in which case they never touch, so there's no solution, no place where these two lines are taking up the same space. Alternatively, like two roads that cross, chopsticks that cross, scissors that cross, X's, two straight lines can intersect in one and only one spot. So these are called intersecting lines. There is an intersection, there is one place, one point of solution. And a third way that lines can intersect is they can relate to one another in space. Let's say that we have this first line here, and then we've got this green line that's going to interact with it. Now if I were to come in here and do that, it would look like all of a sudden my brown line has been changed to green. But if, with gas chromatography perhaps, where you could separate out the green, separate the brown, you could see that this is not just one line here, but it's the green line that was lying on top of a brown line. So you can have two lines that intersect with one another. Wasn't that good? I caught it. In an infinite number of places. The two lines just lie right on top of each other. And we know that a line continues forever in the positive direction. And that line also continues forever in the negative direction. And that's another one of our ways in which the study of mathematics, the study of straight lines, is a picture for us of who God is, because God has neither beginning nor ending. Neither does a straight line have a beginning or an ending, or a number system. It goes on forever in the positive direction, goes on forever in the negative direction. So we can have two lines that interact with one another in that they're parallel and they never touch. There's no solution. They never cross. You can have two lines that interact with one another in that they intersect at one single point. Or you can have two lines where you have one line lying down right on top of the other. And these lines are called, big fancy word, collinear. Whoops. Collinear. When lines are collinear, they occupy the same space. How many places are they touching? They're touching everywhere. So you have an infinite number of solutions. I don't think I spelled collinear right, so I'll make up the word there. It means two lines that take up the same space. So you have either the solution is the cursive R, or you can just say all real numbers, or you can say that there are an infinite number of solutions, meaning that all of the real numbers. It's important that you remember the relationship between two lines, because what we're going to do now is we're going to find some ways to determine the exact location of the solution. What you started on with section 7.1 and 7.2 is using a graphing method to find the solution of, or the intersection of two lines. Let's say, very quickly here, I'm just going to sketch this graph. It would be much neater if you were to use grid paper, or if I were to have a board that I could put up here where I had the grid on it. But I don't, so I won't. Let's say that we have this graph, the graph of this line. Okay, this is 1, -1, +1, and -1. What's the equation of a graph with a y-intercept of 1 and a slope of +1, up 1 over 1? Well, this is the graph of the equation y is equal to x plus 1. Do you remember what our equation is? That's the slope-intercept form of the line. That equation is y is equal to mx plus b, where m is the slope of the line and b is its y-intercept. Okay? The slope of the line here is the rise divided by the run. Our rise is +1. Our run is a -1. So we have a slope of 1. You don't need to show a subscript here, a coefficient here. We understand that that just means 1x. The y-intercept is a +1. This is the equation of the line. Now let's say that we have a line that looks like this. And if you were able to distinguish here, you would see that this has exactly the same y-intercept. It's a +1. However, the line is trending downward as you move left to right. That lets you know it's a negative slope. We have a -1 divided by a +1. The equation of this line here, let me see, can you see that? Can't tell. Yes, you can, and I should use the green marker. The equation of this line is y is equal to -x plus 1. This equation tells us that there's a downward slope of -1 the graph of the line crosses the y-axis here at the point where y is equal to 1. That's the y-intercept. So it looks like the intersection of these points is going to be x is 0 and y is 1. So the solution is the ordered pair where x is 0 and y is 1. Now how do we verify algebraically that that's truly the solution? You take the solution set, you substitute into this first equation. Is y equal to the opposite of, what's our x value? 0 plus 1. Forgot to put in what y was, didn't I? What does this tell me y is? Y is equal to 1. So we would say 1. Is that the same as negative 0 plus 1? Well, yes, of course. 1 is equal to 1. So our solution of this ordered pair 0, 1 is a true solution to this equation. But in order for this to be simultaneous equations, the solution to a system of equations, it has to be a solution to the first equation and to the second equation simultaneously, or at the same time. And that's what we're talking about when we look for this point of intersection right here. So, if we have our ordered pair makes this first equation here a true statement, now we see if it's going to make the second equation a true statement. Y is equal to x plus 1. Well, is 1 equal to x, which is 0, plus 1? Well, yeah, of course. 1 is equal to 1. So because the ordered pair 0, 1 is a solution to both of these equations, the ordered pair 0, 1 is the solution to the simultaneous equations. Y is equal to negative x plus 1 and y is equal to x plus 1. And you were able to read that off the graph. But now, let's see what happens. Because what you're finding out very quickly, and what I've talked about a lot, is when you're working with Algebra 1, they sort of artificially manipulate a lot of your equations, the majority of your equations, so that they'll work out just perfectly so that you can learn concepts. But let's just say that we have these two lines. We have our grid here. And I'm going to say that this line here is 1, negative 1, 1, negative 1, except instead of 1, it's 1,000. Negative 1,000, positive 1,000, negative 1,000. And here's our green line. And here is our brown line. Here's our point of intersection. What's that ordered pair right there? Well, between 0 and 1,000 would be 500, maybe 250. Well, maybe x is 250, and maybe y, maybe that's a tenth, and maybe that's y is 100. What do you think about that? Well, no. Somebody else could just as easily say, I don't think that looks like 250. I think that might look closer to 262. And maybe the y, and I don't think that's quite even 100. I think it's 98. See, there's no way here that much of the time that you can possibly show in a visual way the solution to this. So what do? We solve it algebraically. And that's what we are going to be solving in 7.3. So even though I started off saying that this was lecture 7.3, this was really the beginnings review of how two straight lines interact with one another in space. It's also a review of how you find a graphical solution to two straight lines. So I'm going to call this the end of section 1 teaching, part 1 teaching on straight lines, finding the graphical intersection of two straight lines, and you know, it's late at night, that sort of came out a little bit tongue-tied. This is first part of Chapter 7, where we're doing some review on 7.1, 7.2. This is going to be labeled intentionally, though, as Section 7.3, Part 1 on YouTube.